So yeah, another question on gap year. Sorry, another question on gap concept. Let's see. A lot of students are answering 11C4. Let's discuss. So the numbers, I have 20 numbers. I have to write it in a row. In how many ways can you select phone numbers such that the difference between any two selected number is at least 3? So abhi humne kiya tha. Let's let these phone numbers be A, B, C, and D. In total, I have 26 numbers. 4 numbers here ho gaye already. Remaining is 16 numbers that I have to still accommodate. ठीक है? So यहाँ पे कुछ होगा number, right? Let's say it is again K1. Here there will be some numbers in between these two, K2, K3, K4, and say K5, right? And I know K1 plus K2 plus K3 plus K4 plus K5 has to be equals to 16 because total I have only 20 numbers. And for sure, K5 can be greater than equals to 0, K1 can be greater than equals to 0. Now, इसका क्या मतलब होगा? Can anyone tell me difference between any two of the selected numbers is at least 3? Then what is K2?
Greater than 2. Greater than or equal to.
Greater than equals to 2? Let's see. See, difference between any two of the selected numbers is at least 3, right? So for example, let's say let's say I have two numbers, right? 1 and 4. Here, the difference between 1 and 4 is 3. I want the difference to be at least 3. So how many numbers are there between 1 and 4? 2 and 3. It means that the difference of 3 implies that there are at least 2 numbers between them, right? Which means if I'm just arranging the numbers sequentially, right? That okay, A is less than B, less than C, less than D, right? If I'm just arranging them sequentially, they too can't be consecutive, which means minimum I have to have 2 numbers between them. So this has to be greater than equals to 2, this has to be greater than equals to 2, this has to be greater than equals to 2, right? Which means just give this minimum sum is 6. You remove 6 from here, this becomes 10. 10 plus 1, 2, 3, 4. 14. C4 comes your answer. If this is clear, let's move on to the next question. Again, it's just the generalization of the last question, so I'm not going to discuss this. It is exactly the same. You can try this at home. Yeah, let's try this one. In how many ways can you arrange 4 numbers from this written consecutively such that all the 4 numbers are consecutive? So the numbers are like this. You have to choose 4 numbers from this such that all of these 4 numbers are a consecutive. Which means you first of all have to select 4 consecutive numbers from here and then you have to arrange them. Is the question. In how many ways can you select 4 numbers such that they are a consecutive? या तो 1 2 3 4 कर लो या 2 3 4 5 कर लो 3 4 5 6 till 17 18 19 20. So I have what? 1 2 3 4 2 3 4 5 3 4 5 6 till 17 18 19 20. In how many ways can I select 4 consecutive numbers? 17 ways. Then once you have the 4 numbers, how do you arrange them? 4 factorial. Very simple. Clear, everyone? Why was it taking so much time? Very easy question. Again, a very simple question. We have done such questions in the past. In how many ways 35 identical marbles can be distributed amongst 5 boys such that each boy gets an odd number of marbles? 15-20 seconds question. You have 5 boys, right? How do you, let's say the boys are A, B, C, D, and E. This method is always applicable whenever you are putting similar to different. So here marbles are similar, boys are different. So whenever there is a similar to different wala type, you always apply this. Let the boys be this. इसके पास कुछ marble होगी, इसके पास कुछ होगा. In total, the number of marbles with all the 5 should be equals to 35. Now the only constraint we have is everyone has an odd number of marbles, which means odd number matlab it has to be of the form 2k1 plus 1. It has to be of the form 2k2 plus 2, 2k2 plus 1. It has to be of the form 2k3 plus 1, where k1 can be anything greater than equals to 0, because when a k1 is 0, it is 1. So yeah, minimum इसके पास 1 हो सकता है. When K1 is 1, this is 3. Yes, it can also have 3. So the only constraint you have for all the K1, K2, K3 is it has to be greater than equals to 0. So that's it. You replace everything with this new variable 2K plus 1 and then do equals to 35. There will be plus 1 from each of the 5 variables. We'll subtract this. This will be 30. There will be 2 from each of the 5 variables. You will divide this by 2. So the new variable will be K1 plus K2 plus K3 plus K4 plus K5 equals to 15. There are 5 signs. Sorry, there are 4 positive signs. So you simply write answer as 19C4. I didn't do it completely, but I hope because we have solved so many questions of this type, this is clear now. तो अभी तक हमने देखा कि whenever it is similar to different, ये a plus b plus c equals to something करके will solve it. Similar to similar तो बहुत simple है. Different to different भी बहुत simple है. It is nothing but that 3 into 3 into 3 is equals to 27 वाला question that we did, right? Where letters are also different, envelopes are also different. The last concept is different to similar. Again, it's not a new concept. Just for the sake of completion, I have written this as a new concept, but it is the same that we have already done, right? जहाँ पे envelopes were same but letters were different. So we had 2 methods, right? या तो हम individually cases बनाएंगे and we don't arrange them. Or second method was हम पहले we will assume it as different to different. We will find ordered number of solutions and then we will subtract those cases A, B, A, divide by 3 factorial plus A, B plus A. Right? So that framework that we just discussed when we started this class is the same framework we have to apply here. So hence, I said, right, that we'll do a couple of questions so that it will become very clear to you guys. Okay. So number of ways of putting 4 different books to 5 similar boxes. Mostly, I'll give this question as a homework to you guys. You guys should try it. I'll try one difficult question than this in the class. So let's solve this one in the class and let's do the last question as a homework. So a question is number of ways of putting 5 different books to 3 similar boxes. You can apply any method that you want. Let's solve it. By the way, all the answers, 5, 6 answers, all the answers are incorrect. Okay? So let's pay attention here. First method is we'll go by that a conventional method, but this is the last time we are using that conventional method, then we'll not use it. So we have 3 boxes, right? Let's say the box B, 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 and B. Number of ways of putting 5 different books to this, right? In how many ways can I put 5 books here? Either 5 in 1, 0, 0, 4, 1, 3, 2, 0, or 3, 1, 1, 2, 2, 1. That's all, right? There is no other method. Everyone clear so far?
410 second class.
Oh, sorry. Yes, thanks. This is 410. Yes. ये सबको clear है? Basic एकदम. Always go if this is the only method. Like this is one of the smallest methods to solve such questions. हमेशा group कर लो. Now individually count the cases. In how many ways can you do it? 5C 5 number of ways. Of course, see, you can't arrange them. Why? Because these are the same boxes. So it doesn't matter whether this is in this box or that box. It's the same. Similarly, here 5C4. Similarly, here 5C3 into 2C2. Right? This one is the catchy one, and I think all the students who have given the answer have done the mistakes here only. What is this?
So grouping tha na isme.
Yeah. Yes, correct. So what is this? This is nothing but 5C3, right? Once you have selected, say, 3 books, then you put it in any box, right? Now the remaining 2 books, separate them and then they put them in either of the boxes. So students who have done 2C1 here have done the mistake. It is not 2C1. It has to be 2C1 by 2. Why 2C1 by 2? Because see, once you have two books, right? For example, you have books B1 and second book is B2. You have to put them in 2 same boxes, B and B. In how many ways can you do it? Whether you put B1 here or you put B2 here or you put B2 here or B1 here, it is the same. So you have to divide them by 2 by fundamentally thinking, right? In the same fashion, how do you do this? You select any 2 books, put them in this, right? Then you select, sorry, 5C2. Then you select any 2 books, put them in some other box. The remaining 1 book is put in the last box. But again, you will have to divide this by 2. Why? Because this will have cases where the 2 books in the first box goes to the 2 books in the second box, and that is counted differently here. Hence, you will have to divide it by 2. Now, if you just solve it, you will get the answer as 15. Clear? How do we solve by only grouping method? Everyone? I saw a lot of incorrect answers, but is it clear to you? All the students have attempted this? Perfect, yeah. Cool, thanks. Now we are talking about the shortcut that we don't have to do all of it every time, right? So how do we do the shortcut? Of course, there's a proof for the shortcut. If you're interested in proof, you can contact me. In the interest of time and everyone's interest, I'll not go into the proof right now, but it is the same method that we discussed earlier, right? We first of all assume this to be different, this to be ordered. Ordered का क्या मतलब होता है कि यार these are different boxes. So had these been different boxes, तो number of ways कितने होते बताओ? If the question was 5 different books in 3 different boxes, क्या आंसर होता? यार 5 बुक्स है 3 बॉक्सेस है, बुक्स को बॉक्सेस में डालना है. How many number of ways are there? 3 to the power 5 ना? मतलब why are you doing so much of complication? 7C2 कब होता है? When similar books होती है. Similar to distinct में we apply that method n plus r minus 1 cr minus 1. ये तो different to different है. First book can go in 3 boxes, second book भी 3 option है, third के लिए भी 3 है, 4 के लिए भी 3 है, fifth के लिए भी 3 है. So it is 3 into 3 into 3 into 3 into 3, which is 3 to the power 5. And if I'm making this mistake, you're probably clubbing a lot of concept. हमने इतने टाइप के क्वेश्चंस किए. Remember, letter envelope problem. 3 different letters, 3 different envelopes. First letter can go in 3 envelopes, second can also go in 3, third can also go in 3. So the ordered, hence, see, अगर वहीं गलती कर दोगे, then तो this method is not good for you. But my expectation is you will directly say different to different का कितना होगा? 3 to the power 5 minus, बताओ क्या होगा फिर? What will we subtract?
A, B case or
Good. A, B case minus A case with arrangement by 3 factorial.
Yeah.
Plus A, B case
A, B,
only once and A case only once. Very good. So please go. We have already solved this question. The answer to this question is 15. I would expect you guys to put the values here and solve this once. And then cross check so that you can get confident. Whatever questions we have solved so far with the grouping methods, please solve it using this method. This will really simplify your understanding, right? Because you will get the answers within what 20-30 seconds by directly applying this. And at times you can just look at the question and see कि ठीक है यार, essentially तीनों boxes में same number of books तो आ ही नहीं सकती. So A case तो impossible ही नहीं है, right? And A, B को you only have to count it once. So just by looking at the question, you can say like what will be the answer. ठीक है? Sure. Perfect then. Let's move on to the next concept, but this is a homework. Apply this method here. Try to fit in. Try to get answer by this method. Answer should be 15. And then apply the same concept here in the last question that I gave you as a homework. Exactly same method. There's no change. With this, let's move on to the next concept. Here, number of rectangles, number of squares. Okay. I think this is a simple one. Everyone, I'll give you 20-30 seconds. How many rectangles are there in a 3x5 grid? This is 3 cross 5 grid. 3 rows and 5 columns. Number of rectangles. How do we find the number of rectangles? Maybe let me ask, who do I ask? Let me ask Akanksha. Please explain.
Hello. Yeah. So first, I've taken number of squares and rectangles of height of unit 1. Like I've considered like 5 units.
Okay.
So for the first one, I've taken 5 and in bracket 3 plus 2 plus 1. Like in terms of, so this makes it 30 as a unit.
Sorry. Not clear to me. Can you explain again?
Okay. So this method is kind of different from the one that you just explained. I'm using a different one.
Okay.
So I've calculated total number of squares and rectangles as 90.
Total number of rectangles and squares is 90.
Yeah.
How did you do it?
Like in a unit.
Okay. And how did you count it as 90?
Because I took 5 units and I added 30 plus 24 plus 90 plus 18 plus 12 plus 6. And all of this resulted in 90.
Okay. Fair. Okay.
Then I subtracted the number of squares, which was 26.
But why did you subtract the number of squares?
Because we want rectangles, right?
So,
yeah, I'm sure. Like I'm a little confused. Like my first answer was 90 and then it was 64. Maybe you can explain that for me.
every square is a rectangle.
Okay.
So unless explicitly mentioned in the question in CAT that you have to find pure rectangles, or you have to find rectangles such that length is not equals to breadth, or you have to find rectangles excluding squares,
Okay.
consider that it includes square.
All right. Thanks. Yeah.
So see, like what do we need to form a rectangle? We need any 2 horizontal lines and we need any 2 vertical lines, right? If I have 2 horizontal lines, if I have 2 vertical lines, I'll be able to make a square. So how many horizontal line do we have? This is the first horizontal line, this is the second horizontal line, this is the third horizontal line, this is the fourth horizontal line, right? I just need any 2 horizontal lines, right? I'll select any 2 horizontal lines. Similarly, how many vertical lines do I have? 1, 2, 3, 4, 5, and 6. I have 6 vertical lines. I'll select any 2. Solve it, you'll get 90 as the answer. 6 into 15. All we need is 2 rectangle lines, 2 horizontal and 2 vertical lines to be able to form a rectangle. Now, let me ask this question. So in the same question, how do we calculate the number of squares and then subtract it from 90? Maybe I'll choose the same figure and I'll let you guys try. Find the number of squares here. What could be the length of the squares? It could be of dimension 1 cross 1. It could be of dimension 2 cross 2 and it could be of dimension 3 cross 3. 4 cross 4 ka to ho hi nahi sakta, right? Because maximum I have 3 squares on one side. So you have to find the total number of 1 cross 1 squares, then 2 cross 2 squares, and then 3 cross 3 squares, and then add them. How do you do it? How many 1 cross 1 squares are there, guys? This is 1, this is 1, this is 1, right? Similarly, 3 here, 3 here, 3 here, 3 here. So given that we have 1, 2, 3 cross 5, we have 5 grids here and 3 grids here. I have a total of 3 cross 5 is equals to 15 1 cross 1 squares, because every small one is a 1 cross 1 square, right? Clear? How do we have 15 1 cross 1 squares?
Yes, sir.
Then how do we find 2 cross 2 squares? What is a 2 cross 2? 2 cross 2 is this, right? This is the first 2 cross 2. So I'll start from here. Similarly, I'll start from here. I'll start from here, and the max I can go is till here, right? So I can start from this position, I can start from this position, I can start from this position, and I can maximum go till there. Because we have 5 grids, it is nothing but 5 minus 1, 4. And why 4? Because see, it could be either this 1, 2, 3, and 4, right? You can also manually check it. Now, whatever you had here, similarly, you can also have it on the top. 1, 2, 3, 4. So it is nothing but 4 into 2. Or if I have to write this in a pattern, it is nothing but 2 into 4 is equals to 8. So if you see the pattern, 3 into 5 पहले कर लिया, 3 में से एक subtract कर दो 2, 5 में से एक subtract कर दो 4. Similarly, 3 cross 3 कितने होंगे? 1 cross 3, which is nothing but 3, right? Like you can also check it. This is 3 cross 3, 1, 2 and 3. You have only 3 1 cross 3. So pattern is you find 1 cross 1 and then keep on subtracting 1 from each of the digit till you get 1. कितना हो गया answer? 8 plus 3, 11 plus 15, 26 squares are there. So the answer to this question is, how many squares are there? 26. How many rectangles without squares? 90 minus 26, 64. But this is clear. In this, how many rectangles are there in the whole figure? Time up. How many rectangles are there? Very good. Everyone clear? 7 lines there. So 7C2 into 7C2 is the total number of rectangles. Next question. How many squares are there? Again, there's a pattern. You don't need to solve it. But very simple. Last 10 seconds, how many squares are there? You start with finding 1 cross 1 square and then keep on reducing 1. So how many 1 cross 1 squares are there? Just answer this. How many 1 cross 1 squares are there?
36.
6 cross 6, which is 6 square. Similarly, 5 square plus 4 square till 1 square. This will be your answer. 4 square plus 3 square plus 2 square plus 1 square, right? So whatever is this will be your answer for the number of squares. Here, everyone, how do you find the number of squares? 6 cross 6 plus 5 cross 5 plus 4 cross 4 till 1 cross 1. Then third, in how many ways can you go from A to C without going through B? You can only go horizontally right, vertically up, and diagonally northeast direction. Try this. A very good question. In how many ways can you go from A to C without going through B? Try this properly. It's a very good question. So you first of all find the total number of ways of going from A to C, and then you subtract all the cases where A goes to B, right? That's how you find the given answer. Also, diagonally is also allowed, right? This question says that you can also move diagonally. So just take that into account. These dotted lines are also allowed. Okay, this is not easy. Okay, let's see. You can solve this. But cool. I think at least you have brainstormed like what needs to be done. See, this is slightly tricky. In how many ways can you go from A to C without going through B, right? So first of all, let's forget about any constraint. Let's simply say in how many ways can we go from A to C. So how many, so see, from A to C, he can take this way. He can take maybe this dotted line. He can take some horizontal, vertical, and diagonal, right? So it has to be some combination of horizontal, vertical, and diagonal. Let's consider that, okay, there is no diagonal line at all, right? Then if there is no diagonal line, user can only go from A to C using some horizontal and vertical, right? How many horizontal lines will he have to necessarily cross? See, he has to move from here to here, right? At least, and then he has to move from here to here. So no matter which path he chooses, first line, second, third, fourth, can I say that he necessarily has to take 4 horizontal steps? So 4 horizontal steps he has to necessarily take. If he has to come from here to here, and similarly 1, 2, 3, 4, 5, he has to necessarily take 5 vertical steps if diagonal is not allowed. How many of you are clear with this? If he has to, so if this question would have been, say, diagonal to hai nahi, right? this diagonal is like a new concept that I've introduced so that this question becomes really complicated and we learn it. Majority in mocks in cats, diagonal का concept नहीं रहता है. It's simple. कि people can't move diagonally, they'll simply go from A to C. Then the answer is like very simple, right? You have 9 ways to see. If you have to go from A to C, you necessarily have to take 4 horizontal steps and 4 vertical steps. Now, whether you take all the 4 horizontal साथ में, then 4 vertical, or you take first horizontal, second vertical, then 2 horizontal, then 1 vertical, then 1 horizontal, and then 3 vertical, it is up to you, right? So it is nothing but very simple. How do you arrange these? 9 factorial by 5 factorial into 4 factorial number of ways. So in CAT, if there is no diagonal ka concept, then the number of ways in which you can move from A to C is 9C4 or 9C5 or this. Clear? Until now, how do we solve it without diagonal line? Perfect. Now, can you just try to think ki if I introduce one diagonal line, what will be the impact on horizontal and vertical lines? If I introduce one diagonal line, say for example, I am introducing this particular diagonal line, what will happen here? One diagonal line is equals to how many horizontal and how many vertical lines?
एक pair of horizontal and vertical replace हो जाएगा एक diagonal से.
Very good here. So if I introduce one diagonal line, can I say कि एक pair of horizontal and one pair of vertical will get replaced by a diagonal? So if I can use one diagonal line, it will be like this. Similarly, if I have to use say 2 diagonal line, D, D, V, V, V. Similarly, I can use 3 diagonal lines. Similarly, maximum I can use is 4 diagonal lines, right? And you can also check, agar first, second, third, fourth diagonal lunga, I'll only be left with 1 vertical line. Now, how do you arrange them? Now, so it's simple, right? How do you arrange them? For
5
example,
ones.
this. Can you think about this?
8 by 3 factorial, 4 factorial.
See, the only constraint is you don't have to arrange the diagonal line because diagonal to fix hai. If you are taking, say, only one diagonal steps, this is the only thing that can happen, right? So either you take it here, or you take it here, or you take it here, anywhere. So diagonal to ek hi rahega, but the remaining things can be arranged, right? So yeah, again, simple PNC, right? How do you arrange them? You can arrange them in 4 plus 4, 8 factorial by 3 factorial into 4 factorial number of ways, right? Whether you take this diagonal or maybe you take 2 horizontal steps first, then take a diagonal, then horizontal, and then vertical, whatever it is. Right? Similarly for this, ये कितना हो जाएगा 8 factorial by, sorry, this is what 3 plus 2, 4, 7 factorial by 2 factorial, 2 factorial, 3 factorial. Similarly, this will be 4 plus 2, 6 factorial by 3 factorial, 2 factorial. Similarly, this is 5 factorial by 4 factorial. Find these individually and then add them. You will get the answer as 81. Sorry, it won't be 81. My bad. Just solve it once. क्या आता है? Tell me. I think 681. Can someone just cross check? What is the sum coming out to be? But yeah, like whatever this is, right? Then what we have to do, we don't have to include the cases where A is going via B, right? So I will just subtract all the cases where A goes to B. In how many ways can A go to B? Again, same. I need 2 horizontal, 2 vertical lines, right? Or if I replace 1 horizontal and 1 vertical with a diagonal, or 2 diagonal lines. These are the only ways, right? So 4 factorial by 2 factorial, 2 factorial, 3 factorial, or this is the one only, right? So I will just subtract these cases from that. So yeah, I think just maybe take 30 seconds, try to think what we have done. ठीक है, चलो. So these were the number of ways where I go from A to B. Similarly, because you have to subtract all the cases without going B, right? तो हमने क्या किया कि यार टोटल कितना है माइनस, जब B के थ्रू जा रहे हैं, B के थ्रू कैसे जाओगे? A to B and B to C. So this is A to B. Similarly, you will find B to C. B to C कैसे निकालोगे? 2 horizontal, 3 vertical, right? So H H V V V, H D V V, and D D and V. Again, 3 cases. Solve it. Multiply these 2 cases. It will give you A to B and then B to C, and then subtract it with what we had earlier, and you will get your answer, whatever it comes. I think it should come out as 356, but yeah, you can go back and check it. 356 should be the answer. But is the method clear? This is again a very complicated version. Perhaps CAT में तो नहीं आएगा. CAT में if this question comes, it will be without diagonal. But at least I want to give you that flavor कि if this comes as an LRDI set, you guys should be confident on how do you solve it. Everyone, all the students clear? The difficulty level was LOD 4 or LOD 5 in this. Chalo, if this is clear, let's see the next question. Imagine that there is a chessboard. In how many ways can you select a white square and then a black square such that it does not lie in the same row or column as the white? Sorry, I think this is a separate question. I should have added it in a separate slide, but ठीक है. For now, try this particular question. There's a chessboard 6x6. You can assume this as a chessboard. So there'll be 36, right? So 18 white and 18 black units. Now, in how many ways can you select a white square and then a black square such that it does not lie in the same row or a same column? So this is white, black, white, black, white, black, right? For example, you have chosen a white square. Say, for example, see again, in PNG, fundamental is you make one case and then you try to generalize it. Let's say you have chosen this particular case, right? Let's say you have chosen this white. Now, if you have chosen white, in how many ways can you choose black such that it is not here? So you can choose this black. You cannot choose this black. You cannot choose this black, right? Similarly, this is black, white, black, white, black. You can't choose this black. You cannot choose this black. You cannot choose this black, right? So simply, पहला white को choose करने के लिए how many ways are there? You have 18 whites. Choose any white. Now, if you have chosen a white, see, against the column you will have 3 blacks. For sure, you will have 3 black. No matter कोई सा भी white choose कर लो, same column में there will be 3 blacks. Similarly, same rows में there will be 3 blacks. So at least ये 6 black है, उसको तो तुम choose नहीं कर सकते. So out of 18, you can't choose these 6 blacks. So you'll be left with 12 blacks to choose from. And then simple, 18C1 into 20 into 12C1. So your answer, 180 plus 36, 216. Clear? How do you solve chessboard type of questions? Make a case, draw the diagram, and then put the constraint. Perfect. I think today we have learned a lot of concepts. Let's see who can do this. Assume you have 6 colors. In how many ways can you color this figure, each small square, so that only 2 colors are used in each row? And no 2 adjacent squares have the same colors. And no 2 adjacent rows have the same color. Again, guys, the reason why we are doing this is more like a DILR set, which will have these individual parts. Right? So yeah, try this now. Same, make a small case and then try to do it. The reason I usually do not do the last 2 questions, but the reason I'm doing these questions in this class is I expect that all of your level is like really high. So this question is like an LOD 4 or 5 type of question. You won't find it anywhere. But if this is clear, it covers everything. Good. One student has already attempted. Come on, yeah. Everyone should be able to do it. It's not difficult. You just have to start, right? Just start doing it. So for example, start with say this row. Let's say there are these 6 rows, right? So you have 6 colors and every row Now you need 2 colors in every row, right? So then start it. You have 6 colors. You want 2 colors for this row. In how many ways can you choose 2 colors? You can choose it in 2 colors. In 62 number of ways. Say for example, you have already chosen 2 colors, C1 and C2. In how many ways can you paint this row? C1, C2, C1, C2, C1, C2, because C1, C1 can't be parallel. Or you can say C2, C1, C2, C1, C2, C1, right? So it could be either of the 2 ways. So the first row can be colored in 2 number of ways. Now, because you have already painted this row with 2 color, this row mein, how many colors are left? Because no 2 adjacent square should be of similar color, right? So if you have already chosen 2 color, how many colors are left? Total 4 colors are left. Again, same, you can choose any 2 colors from there, and then you can arrange this row into 2 number of ways. Now you have painted this as well, you have painted this as well. Now again for here, see, the only constraint you have here is that no 2 adjacent rows should have the same color, right? So for example, if you have painted this row with C3, C4, so you cannot use C3, C4 here. So again, you have what? 4 colors to choose from. So same 4C2 into 2. Same 4C2 into 2. Same 4C2 into 2. Same 4C2 into 2. So the answer to this question becomes this into this, to the power 5. I remember we have done one question, that house and paint. We have houses, we have some Vibgyor colors, and we had to paint the houses with different colors. That was also of similar concept. Take 10 seconds and let me know if this is clear. Sorry?
That with your color question was somewhat different. No, we had to take one case from it, like we did some kind of unitary method.
Might be. Like I don't exactly remember, but I remember for sure that we have done at least one question of this type somewhere in the past.
Yeah, okay.